The topic of this video is the quantum mechanical model. The essential questions are: what is an atomic emission spectrum, where did spectrums begin, and how do the spectrums relate to electrons? So first we're going to do a quick review of Niels Bohr. He had the planetary model of the atom, which is where the electrons orbit the nucleus just like the planets orbit the sun. He described electrons, and he said that electrons can only be found in certain regions called energy levels. He based this off of the atomic emission spectrum for hydrogen, which looks like this. An emission spectrum is basically a series of lines of colored light that's unique to each element. It's more or less a fingerprint. Just like each fingerprint is unique to a human, the same is true for spectrums. They're each unique to each type of element. So this is an example of a spectrum for iron. This is for carbon. And this is talks about a little bit how the spectrums are created. White light is passed through a prism and it diffracts out the different colors. So when we talk about white light, which could be coming from a light bulb, it's all the wavelengths of light combined. And so when it passes through that prism, it's able to show all the different colors. So it makes what's called a continuous spectrum, which kind of looks like a rainbow. And when you have a single element, only a few wavelengths of light are produced, and that's based off of what energy is available in that gas. So the light is passed through the gas first, and then through the prism, and it creates an emission spectrum. Okay, so because of this, we can create different colors of light. This is actually how we create different colors of fireworks. We're also going to do a lab with a flame test that will show different colors as well. So what does this all have to do with electrons? So you've got different energy levels where the electrons are available to sit, and the atoms absorb a different amount of energy, and they're called quantums, which is just basically a unit of energy. It's a very small amount. Okay, so that energy goes in, and the electrons get excited to a higher energy level. They go further away from the nucleus. Okay, so you see that electron moving away. So now the electron's away, it falls back to the lower energy level, and it emits the same quantum of energy as a specific color of light. So it lets that energy go as it goes back to its ground state, which is its lowest possible energy level, and that's where the atom is the most stable. Okay, so if you look at the diagram below, it's just showing you different energy levels, and on the left it shows you the electrons getting excited to different states. So it jumps away from the nucleus, and then on the right it shows you the electrons falling from those different states back to their ground state, and when they do that, they let off light. Okay, so each line spectrum results from different electrons transitioning, and that's again unique to each element. Okay, so this first one would be a line of red, this next one would be a line of green, and this highest one would be the blue line. And so red has less energy than blue does. Okay, there are no in-between states. It has to fall from one level to the next. It cannot fall partway or be excited to partway to a level. So this is an electromagnetic spectrum, and so what we're able to see is just visible light, which is that very small area in between infrared and ultraviolet rays. Okay, so we'll talk more about the electromagnetic spectrum when we talk about waves.